Hey everybody, how's it going? Today I wanted to look a little bit more in the application realm for conditional statements and then Boolean operators and variables. So what we've done is I looked at all of the resources that I have available, prep books, past AP exams, textbook, all that kind of stuff, and found just every, I guess you could say, category or archetype for a question that involves either an if statement or a Boolean variable or operators. And we boiled it down into like 7 different types. So the first one, just going right into it, is which of the following expressions is equivalent to? So what they do here is they give you Boolean variables A, B, C, and D with a bunch of conditional operators, or I should say compound operators. The not is on the outside there, and they will give you, again, this is multiple choice, right? And they'll give you 5 choices, and they say it's equivalent to which of the following. Now, we don't need the multiple choice questions for this one. Basically, what they want us to do is they want us to somehow simplify this in some way. And the key thing, whenever we see this not operator outside of parentheses, we always want to think of De Morgan's law. Now, De Morgan's law says that I distribute the not to everything inside of the parentheses. And the key thing to see here is that the most general operator, or you can think of order of operations, the one that would take precedence first is this and, which is between these two parentheses, right? So this not operator is going to be distributed to this first expression, the and the second expression. So in the notepad over here, I'm going to showcase here. Let me make it a little bit larger. There's going to be a not distributed to the first one, which is A or B. The and becomes an or because of De Morgan's law, and then the not gets distributed to the second expression, which is C and D. So we've applied De Morgan's law, but now we can see again for each one of these individually, right, for this first expression here, there's a not outside of the parentheses. So again, I can apply De Morgan's law. So it becomes not A and not B. Maybe keep those in parentheses to make it a little bit more clear to read. This one stays an or. And then now I'm going to apply De Morgan's law to the second half of the expression. So it becomes not C or not D. So either of these could actually be one of our multiple choices, right? They could possibly try to simplify only one side of it and leave the other side unsimplified, right? But if we just simplify this by applying De Morgan's law, a lot of times we're going to find one of our answers for this type of problem. Okay, so all they're going to ask you here is basically matching. This in our PowerPoint is logically equivalent to this last step. Actually, it's logically equivalent to either one of these. Okay, but a lot of times this is going to be our answer, this last step. Right? And there could be a not in front of, if there was a not in front of this A in the original problem, the only thing that changes is there was a not A here, so then when you distribute it, a not, right, just makes it A. It has the same truth value as A. Right? So they could change the original problem some way like that, but it doesn't really affect the concept or what we're applying. Okay. For the second type of problem, still looking at Booleans, they may ask us, what's the result of the following Boolean expression? So they say, consider the following Boolean expression, and again, they give us a combination of some compound operators here. We have the not in here, but we also have a relational operator, equals relational operator. And what we can see here is this is actually not comparing two integers, but instead it's comparing two Boolean values. It says, which of the following best describes the conditions under which the expression will evaluate to false? We see problems like this all the time. They could, instead of asking us when it evaluates to false, they could ask us when it evaluates to true, or sometimes they may even go into more further detail and say, when is it true, when is it false? So something like when A is true, then it's always true, or when B is true, it's always true, or if A and B are different truth values, then it's always true, something like that. But we'll just look at this specific problem and they ask, when is it false? So the best way to approach this type of problem is using a truth table. So I have A, which is a Boolean variable, and B, which is a Boolean variable, and then I have this entire expression. I'm just going to copy and paste it into Notepad. Okay, so since I only have two variables, there's going to be four possible combinations. Either A and B are both true, A is true and B is false, A is false and B is true, or A is false and B is false. These are my four possible combinations. And all I'm going to do is just plug these truth values into my expression on the right and see if the overall value is true or false. Okay, so obviously this would take a lot of maybe handwriting it, a lot of tracing just to make it a little bit easier. I'm just going to say it out loud so that we can try to follow it. But obviously if you were attempting this problem on your own, I would probably write it down on a sheet of paper or something like that. So we have not A. Well, A is true, so not A is false. And that allows me to have, if you recall, a short circuit evaluation. As soon as the first part of my condition is false, then the entire AND is false. So this left-hand side of the relational operator is false. Right-hand side, true or true is true. False equals equals true. Are those two equal to each other? They're not. So this is false. All right, second one, for the same reasoning as the first part, A is true, not A is false, so this left side is false. This side is false or true. Well, one of the statements is true, so the whole or is true. So again, I have false or false equals equals true, which evaluates to false. Now false, A is false and B is true. Not A would be true, and B is true. So the left side is true, equals equals true or false. So with an or, only one of the statements has to be true. So B is true, which makes the right side true. So the left side is true, the right side is true. So true equals equals true is true. And the last one, when A is false and B is false, not A would be true and false. For an AND to be true, both parts of the compound operator have to be, excuse me, both parts have to be true. So since the right side is false, it becomes false. B is false, A is false. When both parts of an OR are false, it's false. So the left side of the relational operator is false. The right side of the relational operator is false. False equals false is true. So if we go back to the original question, it says, which of the following best describes the conditions under which the expression will evaluate to false? Well, it's false for these first two, and we can see for these first two is that A is true for both of them. So the answer here, again, it would be a multiple choice, and the correct answer choice would be when A is true, this expression is false. All right, next problem, what's the output of the following code? So for this one, again, we're hand tracing. Right? It says consider the following code segment, int n equals 2, boolean b equals false, and then now we have our first problem that has these if statements in here. Right? If n is greater than 1 and b, n minus equals 2. If not b, or n is less than 0, n plus equals 2, what's the value of n after execution of the code segment? Right. So there's several problems that are like this where they'll give us some code and they ask us just what's the output, what's the value, anything like that. So n starts out at 2. So up here in my notepad, I'm going to keep track of n. n is 2. Alright, and then b is false. There's nothing in here that's changing b, so b is always going to be false. So if n is greater than 1, n is 2, so it is greater than 1, and b. Well, for an and to be true, both parts have to be true, and we know b is false. So this first if statement, the condition's false, so I skip over it. Go to the next one. I'm going to test the next one. If not b, well, b is false, so not b is true, in order for an OR to be true, only one of the parts, right? Only one of the Boolean expressions has to be true. So this is true, so automatically short circuit evaluation. I know that this condition is true, so I'm going to add 2 to n. So now instead of n being 2, it's 4. So what's the value of n after the execution of the code segment? The value of n would be 4. Right? Which values would produce all possible outcomes? So they give us a method that says which of the following test data sets would test each possible output for the method. Basically what they're asking is what numbers can I use so that it'll hit every single branch. Obviously there's a lot of possibilities here, but again this is going to be multiple choice. So they're going to give you 4 options that are not that don't hit every branch, and then 1 option will hit every branch. So in order for us to hit the first branch, we just have to choose any odd number. So we can choose 1. In order to hit the second branch, I have to choose a number greater than 10, but remember it has to make the first condition false. So it has to be an even number greater than 10. So that would be something like 12. 12 is an even number greater than 10. And then in order for us to hit the third branch here, it has to make the first 2 conditions false. So the first condition is an odd number, the second condition is greater than 10. So it has to be an even number that's less than or equal to 10. So we can just choose 2. So this would be an example answer where this data set would hit every single branch, right? The number 1 satisfies the first condition, the number 12 satisfies the second condition, and the number 2 satisfies the third condition, which means the first 2 are false. Okay. Last one, what expression, sorry, not the last one, the next one, what expression would give the code the correct behavior? So here they have this if statement, and we can see that it's missing a condition. So they tell us, consider the following method declaration intended to return whether a number is divisible by 3. So we have some number that's a parameter, and we want to test whether it's divisible by 3 or not. So they want to know what expression can replace this missing condition so that this method will work as intended. Well, if I want to test whether a number is divisible by 3, then I would need num mod 3 is equal to 0. So this would be our condition that we would need to fill in here to test whether num is divisible by 3. And you can see if num is divisible by 3, it will return true. If it's not divisible by 3, then it will return false. So this would give this method the correct behavior. All right, next problem, what value would give the incorrect response? So what they're saying here is that this code segment does not work as intended. So they want to know what number would make it highlight this error. Right? Now there's no syntax errors here, so it's just a logic error. So we have to identify what the logic error is. So again, it's multiple choice. So a good tactic for this one might be just, if they give us 5 answer choices, just test each answer choice one at a time and see if it gives you the correct response. Right? So this code excerpt is meant to just determine whether a number is even, odd, or neither. So what they say here first is if the num mod 2 is equal to 0, it's even. If the number is equal to 0, it's neither, and otherwise it's odd. So the logic error here is that this else, right, this else is attached to the previous if, which is if num equals 0. Right? It's not if, else, it's just if, else. So what happens then is there's a possibility where if it satisfies the first condition, right, it makes the first condition true, but it makes the second condition false, it's actually going to print 2 different things, even, odd. So for instance, with the number, easy one, number 2. Okay, 2 is even, so 2 mod 2 does equal 0, so it'll print even. It tests the second condition, 2 is not equal to 0, and since this else is attached to the second condition, right, it then skips over this if block and then goes into the else, and it prints odd as well. So it's going to print that the number 2 is both even and odd. So we can see how it's going to hit multiple branches because this is not one if, else, but instead it's 2 separate ifs with an else attached to the second if. Right? So there are a lot of different numbers. Basically any even number would not produces the correct output here. And the last one, probably the most difficult, is typically they'll start out with something like, which of the following satisfies the conditions or has the same behavior as. And what they're doing here is they're giving us a code excerpt. It could be a method or it could just be a code segment. And they want to know which of the following code segments produce the same output as the original. So for this one, you can again test a few different values to see if it produces the same one or not, or a lot of times what we have to do is just try to use our logic to see if it gives us the same thing. So for this one, any number greater than 100 tells us that that number is too large, right? And then any number that is less than or equal to 100 is going to say it's within the bound. So I want to have a code segment which produces the same output. So here I can test it. It says if num is less than 101, it says within bound, otherwise it says too big. Well, the first thing to notice here is that num is an int variable, so less than 101 is the same thing as less than or equal to 100. Okay, that's important to understand because there are no integers between 100 and 101, right? Those are all doubles. So less than 101 is the same thing as less than or equal to 100. So that part within the bound is the same as the previous one. Else, so if the number is greater than or equal to 100, it's going to greater than or equal to 101, it's going to say too big. Well, that's the same output, right? Greater than 100 is the same thing as greater than or equal to 101, so that produces the same output. The second one, if num is less than or equal to 100, it says it's within the bound, otherwise it's too big. That's exactly what we said for the first time we were tracing our code segment here. Right, less than or equal to 100 is just the opposite, right, of, it's just the inverse of greater than 100. So this is just flipping the order of the branches, the if and the else, right, but it's the same condition. It's just the inverse. So this also satisfies has the same behavior. And then the third one, if num is greater than 100, it's too big. And then if num is less than 100, it's within the bound. Now this is almost true, right? Or it's almost the same behavior. But what we can see is when num is equal to 100, it doesn't produce any output. So the third one does not work. So for this one, if they ask this question, the correct choice would be both 1 and 2. Right? 1 and 2 produce the same output as the original code excerpt. Right? So these ones are difficult because there's typically not an easy way to actually trace the code, like choosing values, like does it work for 99, does it work for 101, right? We don't know which values we should be choosing, so a lot of times we just have to go through it logically and look at the conditions, see if the conditions are the same, and if they're not the same, like for instance the third one, the conditions are not the same, so for this one it doesn't work. Okay, just as an administrative note, if we look back at our Google Classroom, right, we can see that under classwork, if we go down to the Boolean if review homework, right, we can see that I have the original PDF version of this homework assignment. I have the video from yesterday, but I'm also going to be posting on here the video from today and both PowerPoints from the video yesterday and the video today. So just note that all of these files are all just being added to this assignment. Right? So you may not get an alert saying I've posted a new assignment because I'm just adding to the same assignment. So you want to go back in and view. Okay. In addition, if you have any questions, right, if you click on the assignment, there's a comments area here. So just make sure you're adding any any questions that you have to the comments area. If it's something about you're not able to view the video, something like administrative like that, let me know. If it's just a question about a specific problem, let me know. Also, you can email me or you can come to office hours, right? The next office hours are Thursday, March 19th, which is tomorrow at 9:30 until 11 or until all the questions are answered, right? If it's 10:30 and nobody is attending the office hours anymore, if there aren't any other questions, then I'm just going to close it early, okay? So hopefully I'll see you guys online tomorrow, and thanks for being here.